Okay. So is DFS clear to everyone?
Yes.
Yes, bro.
Okay, fine. So now what we will learn is we will learn something as diameter. Okay. How many of you know what is diameter in general? Tree छोड़ दो. What is the diameter?
Like
Complete length.
the
Sorry.
circle in circle radius and diameter we'll be having.
Yeah, but what is diameter? I mean, radius and diameter is there, but yeah, what is diameter?
Complete length.
No.
Length from the middle of the circle.
Complete
No,
length between 2 points which
2
passes through the
points.
center of the circle.
So it's, in fact, we should say it's a longest length, not complete length. Okay. Because
Yeah.
we're saying in a circle, this is also a diameter. Okay, if it is passing from the center, because this is the longest length. Okay, so it should not complete, rather it should be longest length. Okay, longest length. So there is something as diameter in a tree also. And given a tree, what do you guys think? Like, what can be the diameter?
Maximum
Node
depth of
leaf.
Sorry,
maximum depth.
maximum depth.
Maximum length from node to leaf.
Which node?
Parent, like the first node. Parent node.
So root to leaf.
Root to leaf.
You should say root. Okay, not parent. Parent is
Ah,
what?
sorry. Root.
Okay, so
Yeah.
one
Ah,
option
that is.
SARS gave is maximum depth, right? Which is again, I guess, the same point, right? From root to leaf. Correct, SARS? Was that?
Yes. Yeah.
Yeah. So basically, actually, that's not the correct definition. Okay. See, when I said diameter in a circle, it's the what? The longest length. So can I say the longest length between 2 points? I mean, if we take any two nodes and if we find the length uh, among all the pairs, the one which is giving me maximum, it's diameter. Okay. In this case, this is the diameter. This diameter.
Okay.
Okay. So it's not from root to leaf. Okay. It's from any two nodes. Okay. And obviously, it should obviously between two leaf nodes only, right? Because that
Yeah.
will give me the maximum length. Correct.
Okay.
Yeah.
Yeah.
Okay. So
Hmm.
diameter is the longest point or longest distance between two nodes. Okay. Now, before solving this, so you got the basic intuition of DFS, right? So just a simple question. If you have to find given two nodes u comma v, okay, given a tree and two separate nodes u comma v, how can you find a distance from u to v? Let's say this is u, v. What should be the answer? What is the distance from u to v?
3.
3.
3.
So you have to find, calculate this. How can you do this?
Like we will be going to the parent, like until
Which parent?
like if we start from u,
Okay.
we will be going to the until root.
Until root. Sure.
Uh, Okay, okay. Sometimes it may be okay. Okay.
Yes, correct. It might be here also, right?
Yes, yes.
But yeah, whatever you are saying, I mean, that idea is nice. In fact, that is one of the ideas we will learn not in today's class, but in binary lifting. Okay, so what you can do is, can I root u? If I root u, and if I just do a DFS, and if I can calculate what is the depth, is my answer done?
Yes, bro.
Right? If I root u, okay, what happens? This one will come here, right?
Hmm.
Yes.
इसका ये वाला it will come here,
Hmm.
and this one is here. So if I do DFS from u, length is 3. So my answer is done.
Okay.
Correct. So for each pair of node, you can do this. Okay. Just a second. My one node got hang again. Yeah. Yeah. So what you can do is, let's say if it is not Q queries, and if you're just asked randomly, can you find the distance from U to V? It is very easy. What you can do is you can start DFS from U and try to find the distance. Okay. But what if I give you Q queries now? Then there is a problem, right? Because if you do DFS from each node, then it is gone. I mean, it will be time limit exceeded, right? You cannot do for all the queries a simple DFS, right? So there is a very good formula for distance between any two nodes, okay? And you have to kind of not verify, but kind of you should understand what it is, okay? So it is nothing but depth of U plus depth of V minus 2 into depth of LCA of U comma V, okay? Now some random terms are obviously present, so probably we can understand. And this calculation, LCA calculation, I will be taking in binary lifting itself, okay? I'm not going to take today because today's focus will be on some LeetCode problems and some techniques on deep trees, okay? So what I am saying is the distance from any two nodes, okay? U to V is nothing but you can randomly pick any node, okay? You can randomly take any node, make it as root, and you try to calculate the depth, okay? What is the depth of U from here?
One,
1. What is the
1,
depth of V?
two.
2.
Now. So this one is done, this one is done, right? 1 plus 2.
Mm.
But what is this? Depth of LCA of U comma V. So does anyone,
Longest common ancestor.
not longest, it's lowest,
Okay.
okay? So lowest LCA is nothing but its lowest common ancestor, okay? And what do you mean by lowest common ancestor? Lowest common ancestor is the common ancestor for both of them which is at the lowest level, okay? So for U comma V, uh, can I say this is the common ancestor for both of them? Ancestor is nothing but it's a parent ka parent, like that, okay? I mean, you know, right? What's the
Yes.
meaning of ancestor? Ancestor
Yes.
is someone like your grandparents or someone like that, okay? So V ka parent is this node, correct?
Yeah.
But is U is a, I mean, is this guy is a parent of U?
No.
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 This cannot be ancestor. But can this be ancestor?
Yes.
Yes, because U is also a child, V is also a child. I mean, in descendant, okay? In the subtree, you can see that both of them, right? Correct? Now,
Yeah.
Yes.
you guys have to tell me for this. For this two node, is this ancestor?
Yes.
Yes.
Is this ancestor?
Yes.
Yes.
So there can be many ancestors, right? So out of them, you have to take the lowest one. Okay.
Okay.
So this is why lowest, because if you go like this, it is generally known as lowest. Okay. So you have
Okay.
to take this one. Now we were talking about U and V. So what is the ancestor for them? I mean, in precise, lowest common ancestor. Can I say this is the one?
Yes.
And what is the depth
Yes.
for this?
0.
So what we got is 1 plus 2 minus 2 into 0, right? Which is nothing
Mm.
but 3. And is the answer 3? 1, 2, 3.
Yes.
Okay, let's take one more example and probably we can move it off. Okay, let's say this is node 4, this is node 5, and this is node 2. Okay, now tell the distance from 0 to 4. 0 to 4.
0 to 4. 2.
0 to 5.
3.
Yeah, this one you have to tell. What is the lowest common ancestor for both of these nodes, 4, 5?
2,
2.
And what is the depth?
1.
1.
So 5 minus 2, it is 3, correct? And now let's calculate. 1, 2, 3. Are we getting the perfect answer?
Yes, sir.
Okay. Now, how this is working, this is something we have to know. Okay. So let's say we have a tree something like this. Okay. Cool. And I have to calculate. Okay. From here to here. So what happens is, if you see, the formula is nothing but d of u, depth of u plus depth of v minus 2 into depth of LCA, right? So this is my LCA, right? Correct? This is my LCA, no?
Yes,
Yes.
sir.
So what is my first term? Can I say my first term is nothing but this edge, this path,
Correct.
right?
Yes.
What is my second path?
Yes.
Correct?
Yes.
So can you see that from here, from red line and pink line, we covered, right, everything? But
Mm.
the one thing which got counted 2 times is nothing but this portion.
Yes, yes.
So
Yeah.
that's the reason what we did is we removed.
Mm.
Okay. Because, and you might ask, why 2 into? Why not 1 into?
2 times it has covered.
It has come 2 times, right? One time for red color, one time for pink color. That's the reason we have removed it twice. Okay. That's the
Okay.
intuition behind this formula.
Yeah, got it, got it.
Okay. Others clear? Manan Sam?
Yes,
Yes,
yes.
bro.
Okay. So this is the formula of distance. Okay. And probably we'll see how to calculate it more efficiently. Okay. But not in today's class, obviously. No. Okay. Next. So what we were looking into is something as diameter of a tree, correct?
Mm.
Yeah.
Yeah. So what is the diameter? It's the farthest distance between any 2 points, correct?
Yes.
Yeah. So again, let's take some arbit arbitrary tree. Okay, a random tree maybe. Okay. Can you guys tell quickly the length of the diameter in this?
5.
5.
Yeah, 5.
5, right? This is 1, 2, 3, 4, 5. Okay, 5. Now how to calculate the diameter of it? Okay. Now I'm not asking you to kind of, pause for a moment, think of something, because this is a very famous technique. Okay. So what you do is, you don't know the root of the tree, right, initially. So
Mm.
you can take any arbitrary node. Okay, let's take, this is our 0, this is 1, 2, 3, 4, 5, 6. Okay, the first thing you have to do is do a DFS from root node and find the maximum distance. Okay, so if I do a DFS from node 0, which node will give me the maximum distance?
4.
4. And what is the distance?
3.
Right? 3, right? Because
Yes.
this is the first, this is the second, this is the third. Okay, this is the first time we have to do, and the claim is this will be one of the endpoints. Okay, because what is diameter? The farthest distance, right? If it is has to be the farthest distance, the one which is giving me the most farthest, can I say that will be one of my endpoint of a diameter?
Yes, sir.
Yes, that is very much intuitive, correct? So we got node 4, which has the distance 3. The second thing you have to do is, any guesses what do you have to do? Okay,
Uh,
yeah, anything if you think.
Again, DFS from the root.
DFS from the, is it DFS from 4 or DFS from root again?
Root.
Okay, and what you will do if you do DFS from root?
Mm.
maximum depth of left plus maximum depth of right tree, subtree.
It is not a binary tree.
Okay.
Okay, I think we can do DFS from 4 again.
Exactly.
Maximum distance.
Very nice. That's the answer, right? If I do a DFS from 4 now, can I say my maximum distance will be nothing but this?
Yeah.
And in fact, that's your diameter.
Yes.
Okay. So
Mm.
the very yeah, just hold on for a second. हाँ क्लास चल रहा है. Okay. Yeah. So what we'll do is we'll pick any arbitrary node, okay, make it as root, and first time we will do a DFS and we will find the maximum farthest node, okay, which will get it as 4 and in this case the distance is 3, okay. The second time what we do is we make 4 it as root, okay. We make 4 it as root, and again if we do a DFS from 4 and try to find the maximum distance, can I say it will give me this one, this path,
Yes, yes,
right?
yes.
And it is nothing but 1 2 3 4 5 6, and in fact that's your answer, right? Okay, so it's very simple that you have to do a DFS from first root, okay. You will get one farthest point, from there you have to do a second DFS and get your answer. So this is what you have to do. Clear?
Yes, bro.
I mean, like for every leaf node, we need to do DFS, right?
No,
Or
why every leaf node? I mean, Sam, like what we do is there can be multiple nodes which are at the same distance, right? But
Hmm.
we just want to calculate the length. See,
Okay, like
You can
how?
consider anyone.
Okay.
see, Sam, this is the node, this is the tree which we took, right? Just now.
Yeah. Yeah.
Let's say we have like this, okay? Okay. Now,
Okay.
when I do DFS from here, let's say I got this node. I am not sure. We might get this or this or this, whatever. I mean, we can take any of them, okay? But we have to take the maximum distance. And what's the distance? 4. Correct?
Like I can get it from root. You are finding
Maximum distance.
maximum distance leaf node, right?
Yes.
Okay. Okay.
Now from here I will do a DFS. If I do a DFS, I will get this path. Isn't it?
Okay. Okay.
Because this will be root now, right?
Yes. Yes.
Yeah. So do you want me to code it up or fine?
So we how to find the maximum of all the distances.
How to find the max? Can you repeat that? I mean, can you repeat?
So previously we have seen how to find the distance between U and V, right?
Okay.
Now how to find like maximum distance?
So this is the maximum distance, right?
Yes, yes. I mean by code.
Okay. So you mean diameter?
No, bro. First thing we need to find the maximum distance between root and the
Yeah.
node.
Correct.
We have seen the distance between U and V.
Okay.
Now U becomes root and we don't have idea of V, right?
Okay.
How to find like maximum distance? Should we iterate through all the leaves?
No. See, you need maximum distance is nothing but diameter, right? In a tree.
Yes, bro.
So diameter of a tree is nothing but maximum distance between any two nodes, correct? So when I when we did the first time, when we have done DFS for the first time, we got U. But
My question is how can we find the U?
okay, we will do the code now. Okay.
Yeah, something we will be getting idea.
Okay. So shall we code it up then, others?
Yes, bro.
Yeah, because how will we know V?
अरे भाई कोड से तो आ ही जाएगा ना अभी तो.
हाँ नहीं, बट वही अगर डिस्टेंस बिटवीन टू नोड्स मालूम कि U और V है, तो अपने को रूट भी नो कि U है, फिर V क्या डिस्टेंस लेना, दैट इज वही क्वेश्चन है.
ओके ठीक है, काम करते हैं. लेट्स राइट इट फ्रॉम स्क्रैच. ओके. And I am not making another class. We will make all the members as static. Okay, just to.
Yeah.
Okay. PS. And whenever I write, I don't know why I don't get here. Is it okay? Okay. What information do we need? Can I say number of nodes?
Yeah.
Yes.
We also need something as adjacency list.
Yeah.
Yes.
We also need something as depth. Correct?
Mm.
Because we need to calculate the max depth, right? So we will do this. Okay. Now. Okay. So what we can do is we can take this and we will initialize our array list. Okay. Then in order to read, we can, so there will be two nodes, right, which will have edges between them. Maybe we can take this as a template from next problem, not to type the entire code. Okay, so is my tree ready now, or do we have to take any more input?
No.
Right.
Yeah.
What we will do a DFS from 0. I know that my parent is -1, I mean it does not exist, and my current depth is 0. Correct?
Yeah.
So quickly we will write a DFS. Okay. Int node, int par, int current depth. Okay. So as soon as we just reached, we know that, oh, we haven't initialized depth par. Okay. Now, first thing, what we will do, can I say depth of node is nothing but current depth. Curd is current depth. Okay.
Yes.
For we will iterate through all of its neighbors. Okay. If it is not parent, then what I will do, I'll just make a
Yeah.
DFS call. I will go to my parent for my, sorry, I will go to my child. This node will become the parent and current depth will increase by 1.
Correct.
That's all. And can I say this is all? I mean, this is it. Nothing else. My DFS is done with all the depths calculated. Okay.
Yeah.
Now, so we have to kind of make it static. Int, what we need now? We need to find the first children. Correct?
Yes. Yes, bro.
Root, we need to find this one. Okay.
Yeah.
So what we can do, int max child, and let's say 0 is the max child. We will just kind of think like this, and we will iterate on all of the other nodes. If my depth of max child is less than depth of I, can I say this?
Max child is length.
Max
Yeah, got it.
नहीं है. Depth is the length array. Okay. Child मतलब कौन सा node, which node it is. So what we have done is 0 is this node, right? Let's say this is 1, let's say this is 2, this is 3, and this is 4. I have initialized depth. Max child matlab which child is having maximum depth. Okay. Now I am iterating on all the nodes. 1 is from 1 to n, right? 1 to less than n. So iska kya hai depth?
2.
So can I say if depth of 2 is greater than depth of 0, वो तो मेरा max child बन जाएगा ना? It will become my max child, right?
Yes.
Yes.
Right? So
Understood.
are you getting the idea?
Yes.
Yeah.
Okay. So now we have the node 4 ready with us, right?
Mm.
And what we'll do?
DFS from that. Mm.
Okay. And same code again. Again same code. Okay.
Mm.
And we can print the diameter is, that's all. Okay. So what we have done with this loop is we have tried to find the first child, okay, which is at the max distance. Now if you see, I have made that node as root,
Mm.
and finally again we need to find the maximum distance, correct?
Mm. Yeah, got it.
So is Sam and Manan, are you guys clear, or
Yeah, clear, bro.
Manan,
Yeah. Yes.
no, is it clear, or if you have
नहीं समझा.
no,
Yes.
so
Bro,
probably
if you want to find only max depth, like instead of diameter, in that recursion call itself, we can check now if depth of node is greater than some global variable. In line number 43.
yes, I understood. Yeah. So what you're telling is we can, yeah, we can do that. You
Oh,
can just have if condition and it's done.
yeah, okay.
Okay. Maybe we can try to run on a smaller tree. Maybe this tree. Okay. I mean this portion. Let's see.
Okay.
So 0. Just how many nodes? 1, 2, 3, 4, 5, 6. There are 7 nodes. So there are 7 nodes. Oh, wait, man. What just happened? The null pointer exception. Oh, okay. Why the exception? We haven't done this. Okay. Maybe I can clear the console up and let's try to run 0. Okay. Someone just remember the structure. Okay. 0, 1, 2, 1, 6, 5 first. So 0, 1, 0, 2, 1, 6, right?
Yeah.
Yes.
Or 1, 5.
1 6.
Okay.
Both.
Yeah, 1, 6, 1, 5. And we have
2, 3, 2,
3.
5.
2, 3.
2 3 3 4 3
2,
5.
5.
2, 3.
3, 4. 2, 5.
But there are 6 edges, right? I mean, for a 7 length, we will have only 6 edges, right?
3 5 is
This is not that, Sam. 1 is 5 is here, right? This 5 is length. This
okay.
length.
Okay.
So what we got diameter is 5. And if you see, I guess we also got diameter is 5.
Okay.
Okay.
Yeah. Okay.
Is it clear?
Yeah.
Yes.
Okay. Fine. So clear, right? This code. I mean, how to find the diameter. Pretty
Yeah.
neat idea on trees. Okay. Good. Now, if I just have to ask you one question on diameter, probably this can be one of the question. Okay. And it came in some online test also, that uh, you're given some tree. Okay. Again, this is not a rooted tree. Can you see this? I'm drawing a random tree. Okay. So what you have to do is you can start from any node. Okay. You can pick any node. You can start from any node and you have to travel all the nodes. What is the minimum distance to cover all the nodes? Is the question clear? Or shall I have to repeat again? Yeah. So you are given some random tree, okay? And the thing is, you can start from any node. What you have to do is you have to visit all the nodes in a tree. Okay, you have to visit all the nodes in a tree. You have to tell what's the minimum distance, what is the minimum time, or what's the minimum distance to cover all the nodes. And assume that if you cover one edge, it will cost you one unit of time, something like that. Okay, so you can start from any tree, any node, and you have to tell me what's the minimum time to cover all the nodes. Okay, is it clear now? Question.
Yes, sir.
Yes.
Okay, so this is one question which appeared in online test. Okay, so maybe I can give you easiest version first. Okay, the easiest version would be, and you have to answer it little quick. What if I have to uh, start, visit all the nodes and come back again? Then how? What will be the cost, or what will be the time? I have to start. I can start from any node. I have to visit all node, and I have to come back to the same node where I started. So in that case,
2
what
into depth.
2 into,
Depth of
but here you did not root any tree, right? So what's depth?
number of edges in that case.
So is this your answer, or?
Yes, yes.
Yeah, so this is correct, because what you do is you can pick any node, let's say this node. Okay, so you have to go and come back, right, every time. So can I say that I will, for each edge, I will travel 2 times, because I have to go and I have to come back again. So this is your answer.
Yes.
In case if you are if you are having little doubt, maybe I can go like this, I can go like this, like this, like this. Something like this. Okay, there might be some better path, but yeah, you can understand, right? If you have to go and come back, it's always 2 into e, because one time for going and one time for coming. That's all. But now the question is little different. The question is, you can start from any node, but you need not to come back again to the same node. Okay, the only requirement is you have to visit all the nodes. That's all. Now what will be your answer?
If we start from any node, if we
Yeah.
find it, take the depth. What?
If you start from, sorry, can you repeat again?
If we start from longest, like from any node, like for example, right corner one,
This one.
from anywhere,
Okay.
if we find the
Mm-hmm.
longest depth,
Okay.
4, 5, 6, and no, sorry, 9, 9.
By the way, was the first idea clear? Why it is 2 into e?
Yeah. Hmm.
SAS, was that clear?
Yes, bro. Yes.
Yeah. And I kind of made a diagram now. You can see. Okay. Everywhere, any age if you take, there will be only 2 pink arrows. Okay. So yeah, 2 into e. But now there is only one different, and you have to kind of find it out. Okay. Okay. We have to cover some ideas. Okay. So I'm just going with the solution. So can I say, if I take the first question, my answer is 2 into e, right?
Hmm.
But now I have to stop somewhere, correct?
Hmm.
Yeah.
I need not to come back. So there is something subtraction, right?
Yeah.
So in order to minimize this, this is the expression, right? 2 into e minus something we have to subtract. Why we are subtracting something? Because we need to stop somewhere, correct? So let's say this is value x. So x should be longest or x should be smallest in order for this expression to be smallest as possible.
Longest.
Longest, right? Because if x is more, can I say 2 into e minus x will be small?
Yes.
And if you see, somehow we have to stop between 2 points, right? Because we need not to come back again. We will travel all the edges, but we will stop at 2 points and we will not cover that. Correct?
Yeah.
So can I say, if x is nothing but diameter of a tree, which will be the maximum length, can I say this expression will be minimized?
Okay. Yeah.
What is my diameter?
4.
4.
And what is 2 into e?
4. Sorry, 8, 8.
Actually, there should be one more just to visualize more better. Okay. So it will be nothing but 10 minus 4, right? Which is nothing but 6. Correct? True?
Yeah.
Now, if this is the diameter, let's say this is the diameter. This is one path, right?
Yes.
Except this, every other path has to be traveled twice just to come back. That's the reason we wrote 2 into e. But now there is one path, which is this path, this red one, which shouldn't have to travel twice. Correct? Because if I can go from here, and if I just go here, come back, and again go here, can I say the diameter path I am traveling only once?
Yes.
Right? So
Yeah.
the answer is x should be the diameter. That's all. The length of the diameter. That's the question. Okay.
Okay.
Yeah, it appeared in some online test, so that's all. Cool. So is it clear? I mean, the diameter. What's the diameter?
Y- Yeah, yeah.
So
Yeah.
in cases if you have to think of the largest or something like that in questions, think in terms of diameter. Okay. There can be one more beautiful question. How many diameters exist in a tree? Okay. So that's little. I can share the code, but it's a little long. Okay. But yeah. Okay. So okay. So shall we move to the next concept, or do you want me to discuss more on diameters and stuff?
Any ideas like this also fine, bro. If you want to discuss.
Not ideas, but
I mean,
there is this one concept, center of a tree. Okay.
okay.
So what is center in a circle?
Equidistant from all the
Yeah.
points.
And like, can I say all the diameter passes through center in a
Yes.
circle? So similarly, all the, what we say, the diameter of a tree passes through center. Okay. So like in this case, the center is this one. So you said equidistant, right?
Yes.
So this, can I say this node is equidistant for the diameter endpoints?
Yes.
So this is nothing but center of a tree. Okay. So in the first question is, how many centers in a tree? One, two, three, or infinity? I mean n, not infinity. It should be n actually. So take a wild guess, or maybe you can try to think for a minute that how many centers can exist in a tree? One, two, three, or n?
One.
Okay. Others?
More than one also. Having the same length, right?
Okay. So it should be two, three, or n. Which one?
N.
Manan, which one do you think?
Wild guess.
नहीं, वाइल्ड गेस तो मैं बोला, तुम लोग का काम है थोड़ा सोच के बताना. Think, I mean, which can be. सर्कल में कितने सेंटर्स होते हैं?
1
तो ट्रीज में कितना होना चाहिए?
n भी हो सकते हैं.
Okay, at least SARS is little better, but I don't know why Sam and Manan you guys have told n. How there can be n centers, man, in a tree?
Like diameter means like having the length, right? Suppose length is 5.
Okay,
Like we can have any
I'm
other,
I'm talking about center, not diameters, right? I
like
asked,
in diameter only, like a center, right? Will be.
yeah, in diameter, the center node. Say this is a
If-
tree.
Yes, if you have n diameters, like a same length diameters, there may be chance, right?
Oh, okay. Is it you're no, Sam. No, not like that. See, what we just discussed is in even in a circle also, the diameter passes through center, right? So all the diameter will pass through a center. Can I say that in a tree,
Yeah.
right?
Hmm.
So in this case, let's say how many diameters are there in this tree?
2 diameters.
Two diameters, right? One
Hmm.
is this one, and one is
They're
this one,
passing through 1 only.
right? There are
Okay.
two diameters, correct? Now, which is the center?
Root.
Root
Root
is
node.
the center.
Hmm.
There can be trees like this also.
Yes.
Now, how many diameters?
4.
Exactly, it's four, right? Take one, take one into, I mean, two into two, four, right? But how many centers now?
We can take a like a top any one.
Exactly,
This
right?
one or that one, yeah.
Yeah, so this or that. So now, can you see there are two centers?
Yes.
So in a tree, there can only be two centers, okay? There cannot be more than two centers because of the fact that if you extend one more, okay, let's say if I extend one more, then this will be center, right?
Mm.
So that is the reason there can only be two centers in a tree. There cannot be more than two centers, either one center or two centers, okay? That's all.
Okay.
Question for you guys is you have to do as a homework, print the centers of a tree, okay? Got it? Print the centers of a tree. So in this case, what is the length? 1, 2, 3, 4, 5, 6. If the length is even, okay, if the diameter length is even, there will only be one center. If it is odd, there will be two centers. That's all. Okay. Is it clear? Because अभी का length कितना है? 1, 2, 3, 4, 5, 6. Right? There are 6. If there is a 6 length, if it is an even length, then there will be only one diameter. But in the earlier case, you saw that there were only 5, right? 1, 2, 3, 4, 5. That time they were two centers. So if the length is odd, then there are two, otherwise it's one. That's all. Clear?
Yes,
Yeah.
bro.
Okay. So the question is print the centers of a tree.
Centers means you mean nodes, right?
Yeah, you have to, let's say this is node 3, this is node 4, you have to print 3, 4.
Okay.
If there is one center, you have to print that one. That's all.
Okay.
Give a try. Manan,
Yep.
will you give a try?
Hmm. Yes.
You understood the concept, right? DFS.
Yes.
Yeah, so it should not be hard. Okay.
Hmm.
मतलब pen paper लेके बैठो, Sam and others. Okay. And you can see that if I get the length, if I just travel d by 2 distance up, that is my answer. Okay.
Okay.
Now, let's move to next.
Bro, like why this length is even then one diameter and odd two diameters. I did not get that clear.
See, man, we just talked, right? What happens in this case? The diameter length is
5.
5, right? 1, 2, 3,
Yeah.
4, 5.
Yeah.
Correct. So can I say this can also be one diameter, this can also be diameter?
Yes. Yeah.
But if I just extend it, can this be diameter?
No.
No, because there are 2 and there are 3.
Yes.
But if I make this as a diameter, there is 3, there is 3 exactly.
Okay.
So that's the reason if you see in the case of 1, 2, 3, 4, 5, in the case of length 5, which is an odd number, there were 2 diameters, right?
Okay. Yeah. Yeah. Got it. Got it.
ठीक है चलो clear, right? Diameters, centers.
Yes.
And the question for you guys
Yes.
is try to find the centers of a tree, and in case if you're thinking that you want to kind of extend yourself, you can try to find how many diameters exist in a tree. It's little hard, but yeah, it's doable again. But yeah, first try to print the centers. Okay, so next question what we'll take is probably the favorite for some of you guys. Contribution. Okay, contribution on trees. Okay, so let's take an inspiration problem for this and maybe we can try to do something. Okay, so given a tree, again you can probably root it anywhere, or maybe I am just giving you the root. Okay, let's write it some numbers: 0, 2, 3, 1, 4, 5, 6, 7. Okay, now what you have to do is you have to find double summation. Do you guys understand the meaning of this?
Mm.
Okay, so that means you have to take the path for each pair of node and you have to sum it up. Okay, just to give an example, let's say 0 comma 3. Okay, what is the distance between 0 comma 3? It is 1. What is the distance between 0 comma 1? 2. What is the distance
1.
between 0 to 1, man? 0 to 1, it's distance 2, right?
Yeah.
Not 1, distance is 2. Clear, Sam?
Yeah. I did not tell 1, bro.
You said 1, right?
Okay.
No?
No. 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 No.
Okay. ठीक है.
Okay.
What's the distance between 1 comma 5? 4. So you have to take for all nodes and sum it up. Now is it clear? Is the question clear?
Yeah.
Yes.
Okay. For all nodes, you have to kind of like do the distance and do summation of them. Okay. Summation of the question is summation of all pairs of distances between two nodes. Okay. I mean all pairs of distances because pair is 2. So summation of all pairs of distances.
Yep.
ठीक है. Question तो clear है. Correct?
Bro, why double summation you have mentioned? Is there any reason?
Yeah, so double summation is, see, whenever there are two parameters there will be double summation. If there are number of
Oh.
parameters equals to number of
Okay. Okay.
Mhm.
okay. Yeah, so the question is clear, right?
Yeah.
Chalo, first task, number of nodes are less than or equals to 1000. हो जाएगा? Can you guys do brute force?
Depth of all
Nice.
nodes.
So, I mean, depth is correct, but that is for one node, right?
DFS.
Yeah, correct. Yes, itself. But
नहीं अच्छा.
Iterate on all the nodes and
yeah. So can I say if it is less than or equals to 10 cube, can I make all node as a root and try to find distance?
Yes.
And is my answer done if I do for all the nodes making as a root? Clear?
Yeah.
हो जाएगा ना? That three of you can do, right?
yes, bro.
Manan?
Yes.
Okay. Next. Now
No, we cannot.
we cannot, right? Because time limit exceeds. Because if we do two for loop, I mean one DFS would take n time. So if we
We go.
if we make root for all of them, it will be n into n, which is n square, and it cannot pass.
Hmm.
So we need something better than this. Okay. No. If you see, let's take some random edge. Okay. Let's say I am interested, or we are interested in this edge. Okay. Can I say contribution of this edge plus contribution of this edge plus this edge plus this edge, जितने भी edges है tree में, if I can get to know कि how many times this has been traveled, can I say my answer is done? If I can, what we were doing in the question, we were just trying to go and for each and every edge, right? So
Yes.
if I say that this edge, any edge, if it is, let's say, if it is has a contribution of 10, then can I say if I find this contribution for all the edges, my answer is done?
Yeah.
Okay, let's try to probably you guys tell me which edge should we take and explore. Shall we take this edge or shall we take any other edges? Sas, which one shall we take?
We shall take 3, 4 edge.
Oh, okay. Okay. So what we need is we need a contribution of this. Okay.
Yes.
Okay. So one, we are very much sure 3 comma 4 is one path, right?
Yes.
So we can also go from 3 4 uh 3
7.
4 what
7.
3 4 7, that means 3 to 7.
Yes.
Hmm.
There is 0 to
7.
0 to
4.
4.
yeah, I mean you understand, right? Like 0 to 4, 0 to 7.
7.
So what I'm just calculating is number of paths, that's all. Okay, again one more.
2 to 4.
Okay, हेलो, अच्छा बाबा ठीक है. Okay, right? So we were writing some pairs, right?
Hmm.
And can I say this edge is nothing but all the pairs that whatever we are writing,
Hmm. Correct.
right? So can I say if I try to find it for all the edges present in my tree, can I say my answer is done?
Yes.
So is the overview clear first of all? What we were trying to do, contribution of each edge,
Yes.
right?
Yeah.
Okay, good. Now, how to calculate what is the contribution of this? Okay. Let's take one better tree probably, and maybe we can try to do something. Now, we were interested in finding the contribution of this one. Okay. I'm drawing something, you have to tell me. Okay. So can I say the paths from red to blue is my answer? All the paths from red to blue. All the paths start from any path, any node from red, and end at any path at blue. Can I say that is my answer?
Yes.
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 Right? So what is this? This is what?
Sub.
Subtree, right? So subtree size तो easy है ना find करना. It's very easy, right? Subtree size. What's the subtree size of this? 3.
Mm.
If the subtree size is 3, how many remaining nodes will be? Can I say n minus subtree size of this?
Mm.
3. So whatever the nodes might be. So n minus, if I total nodes are n. Out of n, if I remove this blue portion, can I say I will get my remaining nodes?
Yes.
N minus subtree, okay, which is nothing but
Yeah.
3 sorry, what is 3? 3 is nothing but subtree size into n is how much? 1, 2, 3, 4, 7. 7 minus 3. How much? 12. Can I say there are total 12 pairs which will go through this edge?
We wrote n is total nodes.
Yeah,
S of t is
this one.
subtree size.
Yes.
Then y into 3.
See, again let's explore, okay? This is the subtree, right?
Yes.
What we are interested at? We are interested at this edge.
Yes.
So can I say anything which is coming from red and coming to blue is my answer?
Yes.
So when I say blue, I can go anywhere, right? I can go here, here, or here. Can I say that?
Yes.
So how many total nodes?
3.
3.
So 3. That is nothing but size. Let's say if there were more, then how
More.
can I say this would be 5? Because I can go from here to here, maybe here to here, here to here. So there were 5 paths, right? Can I say that?
Correct.
Is it clear
So
now?
that will be 5 into.
5
Yes.
into,
So it will be 5 then instead of.
yeah,
Hmm.
n minus, if I remove the this one, I will get my remaining nodes, right, in a tree?
Correct. Yes.
N minus 5.
Oh.
So in this case, what we did was we took 3. So 3 into, there was 7 minus 3, which were 12. So there were total 12 paths. So now you can see that we have done the contribution of this edge. Similarly, I can find for this one, all the edges, right? And if I sum it up, is my answer done?
Yes.
Okay? So
Yes.
is the concept clear? The contribution of whatever the edges we have done.
Yes, bro.
Okay, Sam,
Yes.
Manan,
Yes. Sam is not there, but yeah.
Sam is having some connectivity issue, I guess.
Okay.
I just know he left.
Okay, so you guys are clear, right?
Yes, bro.
Okay.
Hey, what was the question? एक बार बोल. एक बार question क्या था?
Question क्या भाई?
अच्छा, ओके. हाँ, ओके, डन. हाँ, ठीक है, समझ गया. या. हाँ, notes है ना. हाँ, ठीक है, डन.
Distance
हाँ, distance. Yes.
between all pairs.
So even if n value is 10 power 8, it could be solvable, right?
Yes, because it is just linear. That's all.
Mm.
I guess Sam is back.
Yes.
Hey man, we are clear. Sorry. Okay, I'm not able to hear. Did anyone hear what he said? Whether he's clear or
No,
not?
no.
He is not clear.
No, he's not.
Can you?
His voice is not clear first.
Not clear.
Yes, that is correct.
I had joined from my mobile data. That's my issue.
Okay, Sam, we are interested in finding this edge contribution. Okay, so can I say any subtree which is here? Okay, all the nodes which are there in the pink path can go here, right? To this red subsection. If they have to go from here to here, can I say they has to cross via this path, this edge? Correct. So
Yeah.
the
Yeah.
subtree size is nothing but 3. So in order to take this edge and come to any destination on this, there are 3 nodes possible. And how many total remaining nodes you can come from? It is nothing but n minus 3. If I do for all of the edges, I am done. Okay. Clear?
Subtree into n minus I.
Yes. Subtree size into n minus subtree size. That's all. Code करना है? Shall we
Yeah.
code it up, or
Yeah, got it.
are you guys can handle this? Little quick, man. Okay, I have to cover other things also.
Can you
Yeah.
quickly do it?
Manan, will you do it?
So loop करना from all the nodes और
Sorry.
फिर नहीं asking you code के लिए if you loop through all the nodes
Okay.
and contribution from you फिर तुम contribution find करोगे ऐसा है ना?
Yes, वैसे ही है. वैसे ही है.
वैसे ही है.
ठीक है. तो what we need, subtree size, right, this time?
Yes, yes.
Okay. Subtree size clear? मतलब ये तो very basic key.
Yes.
And I am just summing up all of the childs. Okay.
Yes. Yes.
Okay. ये तो clear है. Then we will take some other information also. Okay. Where is scanner? Yep. And we have done a DFS. So our subtree size will be ready, right? Okay. For each node. What is the answer? Subtree
Is it node or I?
Okay. Simple, our formula, that's all. Right? Subtree size into n minus subtree size. Okay. So there is this exception for node 0, because for node 0 this will become 0, right? N minus subtree of size of parent root is n. So n minus n is 0. So there won't be anything for root 0. And from others you will get your answer. Okay, for this node, this node. Okay. This is it. I mean, nothing fancy.
Okay, yeah.
Clear? Others? Manan, Sam?
Yeah, okay, bro.
Yeah.
Clear, right? Are you sure? This one? How we got?
Yes.
Okay. Because again, I'm not coming back here again. That's the reason. If you want anything, just